Okay, so look at this. Seriously, just take a second and look at this image. On the left, you have the Pantheon in Rome. It is basically a giant, unreinforced concrete dome that has been sitting there, just chilling, watching empires rise and fall for nearly 2,000 years. It's pristine. And on the right, that is a bridge built in like the 1960s or 70s. And spoiler alert, it is already failing. It's crumbling. One of these is a masterpiece of engineering that we literally struggle to replicate today. And the other one is, well, it's a liability. It's a ticking time bomb. It's kind of embarrassing for us modern humans, right? We have iPhones and AI, but our bridges are falling down. So in this video, we're going to dive deep into the self-healing city, unlocking the Roman concrete secret. And I know what you're thinking. You're thinking, concrete? Really? I clicked on this channel for Jupiter and aliens. But stick with me, because what if I told you that the secret inside this ancient gray rock isn't just about fixing potholes? It is actually a lost form of nanotechnology. It is a trick that could save the global economy trillions of dollars, slash our carbon footprint, and this is the part that blows my mind. It might be the only way we can actually survive living on Mars. The payoff here is huge, and it all starts with a tiny white rock that everyone thought was a mistake. We are going to bridge the gap between the ancient past and the sci-fi future. We're going to find out why Roman walls healed themselves like human skin, and why our modern skyscrapers are basically dying a slow death from the moment they're poured. We're going to meet the scientists who cracked the code and see how this 2,000-year-old recipe is being used right now to build the next generation of cities. This is the ultimate cold case file of engineering, and we just found the smoking gun. We have this idea, right? We have this chronological bias where we assume that just because we live now in the year 2026, our tech must be superior to the stuff they had back when people wore togas and didn't have Wi-Fi. But when it comes to the literal foundation of our civilization, we kind of regressed. See, modern construction runs on this stuff called Portland cement. It was invented in England in 1824 by a guy named Joseph Aspdin. He named it that because it looked like stone from the Isle of Portland. It's great if you want to build something fast. It sets quick. But fast doesn't mean good. And fast definitely doesn't mean forever. The problem isn't even really the rock itself. It's the steel. We put steel bars, rebar, inside the concrete to make it strong in tension. And that works for a while. It allows us to build crazy shapes. But concrete is like a hard sponge. It has these tiny, microscopic pores. And over time, entropy happens. Water gets in, air gets in, and that steel, it starts to rust. And here is the physics nightmare. Rust takes up more space than steel. It expands. It pushes against the concrete from the inside with enough hydraulic force to literally shatter rock. We call it concrete cancer, and once it starts, it is terminal. And this isn't just, an aesthetic issue where things look a bit shabby. It's a catastrophe. We're spending something like $2.5 trillion a year trying to fix this. That is like a significant chunk of the entire global GDP just thrown into a hole in the ground to patch up rusting bridges. It's a disposable infrastructure model. We build it, it breaks in 50 years, we tear it down, we build it again. It's incredibly wasteful. It creates a massive carbon debt. And honestly, it's dangerous. We're driving on borrowed time. Actually, I want you to try something for me. Next time you're driving to work or walking around your city, just look at the bridges. Look at the retaining walls on the highway. I want you to tell me in the comments, is there a structure near you that is barely 50 years old that looks like it's been through a war zone? Like you can see the rusty metal ribs poking out? Let me know down below. I bet almost all of you have seen this. It's so common we don't even notice it anymore. We just accept that our world crumbles. We accept that things are temporary. But the Romans, they didn't have this problem. And for the longest time, we thought we knew why. We have this book, right? It's called De Architectura, written by this guy Vitruvius way back in the 1st century BC. It's basically the instruction manual for the Roman Empire. And in it, he gives the recipe for concrete. He talks about volcanic ash, pozzolana, which is this magic dust from volcanoes near Naples. And for centuries, we thought, aha, it's the ash, that's the secret. We thought it was just better ingredients, but we were missing something. Something that was staring us in the face the whole time. Enter modern science, specifically a team from MIT led by Admir Mazik. They started looking at these samples of Roman concrete with high-tech scanners, Raman spectroscopy, the works. And they kept seeing these white chunks, little white rocks embedded in the concrete. Now, for decades, archaeologists just looked at these chunks and said, oh, that's just sloppy mixing. They literally thought the Romans, the people who built aqueducts that are dead straight for miles and domes that defy gravity, were just lazy mixers. They thought they didn't stir the batter enough. But that explanation didn't sit right with Mazik. Like, think about it. If you were building the Pantheon, a temple to all the gods, are you really gonna let the guy mixing the cement just slack off? No way! Quality control was everything to them. So the MIT team asked a different question. What if the white chunks, these lime clasts, weren't a mistake? What if they were a feature? What if they were actually the battery pack for the whole system? What if the sloppiness was actually genius? This is where it gets into the chemistry, but I promise I'll keep it simple. The old theory was that Romans slaked their lime, basically mixed it with water into a paste before adding it to the concrete. That's the safe way. It's the cold way. But the evidence from these white chunks suggests they did something way more metal. They did hot mixing. They took quicklime, calcium oxide, which is super reactive, and they threw it right into the mix. And when you do that, kaboom! It gets hot. Like 400 degrees hot. It boils inside the mixer. Imagine the job site in Pompeii in 79 AD. This wasn't a clean lab, this was a messy, dangerous place. Handling quicklime is nasty. If you get it on your sweaty skin, it burns chemically because it is so thirsty for water. So why would they risk blinding their workers? Because of speed and heat. That heat cooks the concrete from the inside out. It forces the formation of these really specific mineral phases that just don't happen when you mix cold, sloppy Portland cement. It's like the difference between slow cooking a brisket and microwaving a steak. The heat changes the fundamental structure, but the heat does something else. Because the reaction happens so fast and there isn't enough water to dissolve everything, you get leftovers. You get these little nuggets of pure calcium potential trapped inside the rock. These are the lime clasts. They aren't mistakes, they're time-relief capsules. They sit there, dormant, waiting. So fast forward a few hundred years, an earthquake hits, or the ground settles. A tiny crack forms. The crack travels through the concrete and, because physics follows the path of least resistance, it runs right into these brittle lime clasts. And this is the magic trick. When rainwater seeps into that crack, it hits the lime clast. The water wakes it up. The lime dissolves, creates a calcium-rich fluid, and flows into the crack. Then it reacts with the air and the volcanic ash and crystallizes. It turns back into stone, calcite to be specific. It literally glues the crack back together. It heals its own wound, automatically. No humans required. It's basically indistinguishable from magic. The scientists actually tested this to make sure they weren't crazy. They made 2 batches of concrete, one the modern way, one the Roman hot mix way. They cracked them both and ran water through them. The modern concrete, it just kept leaking. It failed. But the Roman recipe? Within 2 weeks, the water stopped flowing. The crack had completely sealed itself. It's like, imagine if you got a paper cut and your skin just fixed it. Oh wait, your skin does do that. This concrete is behaving like a biological organism. It's alive. And in the ocean, it gets even wilder. The seawater actually reacts with the volcanic ash to grow these rare minerals called ultangomorite. It forms these interlocking crystals that make the concrete stronger over time. Think about that definition. Anti-fragile. Things that gain from disorder. Modern stuff hates stress. It breaks. This stuff loves stress. It gets tougher. It interacts with the environment rather than fighting it. It's basically the Hulk of building materials. You make it angry, it gets stronger. So we realized that Vitruvius wasn't wrong per se, but he might have been describing the textbook version, while the guys on the ground in Pompeii had hacked the recipe. They figured out how to industrialize longevity, and Masick calls this the Book of Knowledge. He says we don't need to reinvent the wheel, we just need to translate a few sentences from this ancient book into modern chemistry. We need to stop looking at the past as primitive and start looking at it as a database of solutions we forgot. So this isn't just a history lesson. This is the season of cosmic origins, and we are talking about the future. Because this isn't staying in a museum. That researcher, Admir Masick, he didn't just publish a paper and call it a day. He launched a startup called DNMat. They raised millions of dollars to take this Roman recipe and industrialize it for the 21st century. They are building this now. You can buy this tech. It's essentially Roman concrete 2.0. And the implications are wild. Cement production is responsible for like 8% of global CO2 emissions. It's a huge polluter. But if we use this self-healing tech, we don't need to replace bridges every 50 years. We could build things that last for centuries. That means we produce way less cement overall, which cuts global emissions massively. It's like we found the solution to a huge chunk of climate change hiding in the wall of a 2,000-year-old bakery in Pompeii. It's the ultimate recycling of knowledge. Think about the tax dollars. That $2.5 trillion we spend on corrosion. Imagine if we didn't have to spend that. Imagine if we could spend that on education or space exploration or healthcare, instead of fixing the same pothole on I-95 for the 10th time. It's a self-healing economy powered by self-healing rocks. It changes the calculus of how we build civilization. But let's go further. Let's go to Week 5 territory. Let's talk about Mars. When we send the Artemis missions and eventually go to the Red Planet, we have a logistics problem. Every kilogram you launch to Mars costs a fortune. You cannot launch 1 billion tons of steel rebar to Mars. You just can't. And even if you could, the radiation and the thermal cycling on Mars would wreck it. Mars goes from freezing to, well, deeper freezing. It expands and contracts. Cracks are inevitable. We have to use what's there. ISRU, in situ resource utilization. We have to build with the red dust, the regolith. And if your habitat on Mars cracks, you can't just call a repairman. A crack on Mars means you lose your air pressure and you die. The walls need to heal themselves. It is not a luxury, it is a survival requirement. And NASA knows this. They are looking at this Roman tech right now. They're even looking at astrocrete, using biological binders. Get this. They are researching using human serum albumin, protein from blood, mixed with Martian soil to create concrete. Yeah, literally blood and dust. It sounds like a horror movie, but it works. And it echoes the ancient world again. Romans sometimes used ox blood or milk in their mortars. We are circling back to these organic, biological ways of building, Because on a new planet, we are the only resource we have. So imagine a habitat on Mars. A micrometeorite pings off the outer shell. A tiny crack forms. But instead of triggering an alarm, the wall just bleeds a little bit of calcium or a biological agent and seals itself up. It protects the astronauts like a living shell. That is the Roman legacy, taking a pile of dust and turning it into a guardian that lasts forever. See, this is why we call this channel the Unifying Lens. We started this season looking at Jupiter protecting Earth. We looked at lost cities in the Amazon. And now we see that a chemical reaction in a Roman wall is the key to our survival on other planets. It's not a straight line from primitive to advanced, it's a circle. We are relearning the old ways to build the new worlds. The primitive past is actually the blueprint for our future. The Romans built for eternity. They called Rome Urbs Aeterna, the eternal city. Somewhere along the way, we lost that. We started building for the next fiscal quarter. We started building for the 50-year warranty. But if we want to be a multi-planetary species, if we want to be around for another 2,000 years, we need to stop thinking like consumers and start thinking like ancestors. We need to build things that heal. We need to build things that stay. And speaking of building new worlds, next week we are finally leaving Earth. We are going to Week 5, the Artemis 2 mission. It is the first step back to deep space in 50 years. But the biggest challenge isn't the rocket, and it isn't even the concrete. It's the human mind. What happens to your brain when the Earth is just a tiny blue dot and you are totally alone? You do not want to miss that one. It's going to be a psychological deep dive. Make sure you're subscribed so you don't get left behind on Earth. Thanks for watching. And hey, seriously, check out those bridges in your town. Once you see the rust, you can't unsee it. Put the photos in the Discord if you have them. I'll see you in the comments. Stay curious.